All right. So let's say you're working in a relatively large company. Let's say, for example, Disney, right? You're working IT in Disney, and Disney have, let's say, in Disney in Europe, and they have 50 routers, and they have 50 switches. Okay. So I'll just do some routers and some switches across here. Let's say I go. Oh, get rid of that. Some down here, and some down here, and then some switches. So you got all these devices. I'm not even going to link them up because I'm just using them for illustration purposes here. Okay. So you have all these network devices. You got 50 routers, you got 50 switches. Let's say you have firewalls, you got servers. You know, I'm just yeah. So you've let's say you could have 200 IT devices, and let's say you have 4 network staff. Who is tasked with managing and configuring and installing and maintaining all the routers, all the switches. Maybe you got firewalls, you got load balancers, you got DNS servers, you got whatever. So there's a couple of ways you can do this in terms of management of your devices. One way is you can have one password for everyone. Let's say the network staff we have is you got Tom, Bob, Joe, Sue. You got Tom, Bob, Joe, and Sue, right? And you got one network, so you got one password for all of these guys. That all of these guys, Tom, Bob, Joe, and Sue, shares this one password. Okay. And let's say Tom here logs in to this router here. He SSHs into this router, or telnets into the router, and he makes a change, and he breaks the router. Okay. Well, there's a problem with that is that if no one else knew or no one else seen Tom connect in here and do changes on it, then there's no audit trail. Because everyone is using the exact same password. Tom is using the same password. Bob, Joe, and Sue is using the exact same password to log in and configure the devices. Okay, so that's probably not the best option when you have a lot of devices there. Another option is you can have individual usernames and individual passwords. So let's say we look at this, for example, let's say this is R1 here. Okay, you have R1, and on R1, you're going to have to set up these 4 users to be able to access R1. So Tom, Bob, Joe, and Sue. So there's 4 user accounts to configure R1, right? And then another 4 accounts for R2, for R3, or 4. We've got 50 routers, 50 switches. So there you've got how many accounts altogether? 100 multiplied by 4 is 400 user accounts logging onto devices, installing, you know, the details and logging off. That will give you an audit trail because Tom, Bob, Joe, and Sue will each have an individual password, a username and password, but then there's a lot of administrative overhead. Does that make sense? What happens if, say, Tom leaves? You go through all the hassle of setting up Tom on 100 devices, and he leaves after 2 days. So then you have to go and you have to remove Tom from all of these 100 devices, and you have to get another intern in or whoever in, and you say Al. And then you have to set up Al, username Al, password Al PW or whatever, I don't know. So we're looking kind of for a balance between usability, but something that will give us an audit trail. You know, like the one password for everyone is very easy to configure, but it doesn't give us any sort of accounting. It doesn't, you know, you know, there's not much security involved with that. Okay, so there's a set of protocols or a suite of protocols called AAA, AAA. Okay. And AAA, sorry, black pen, excuse me, stands for accounting. Start. Authentication, authorization, and accountability. Authentication, authorization, and accountability. Okay, so there's the 3 A's in terms of security. So authentication simply means I am who I claim to be. I am who I claim to be. So that's what you want to have authentication. So the most simplistic form of authentication is your standard username and password. Okay, so my name is Lee, and then the device will say, well, how do I know you're Lee? I have to prove when I'm logging onto a router. Or let's say, for example, if I'm checking my bank account on my app, I have to prove to the app on my phone that my name is Lee and this is my bank account. And I have to do that by putting in either a 6-digit PIN code or an SMS, or use my, you know, there's multiple different ways of authentication. Okay, most simplistic one is just your username and password. Now all banks now have what's known as 2FA, and 2FA is two-factor authentication. Where before just logging onto a banking app wasn't enough. Typically what they'll do is you'll have to do that anyway, and then they'll have a key or a code which will be randomly generated it'll be like 6 digits, will randomly generated every minute, and you have to put in the code for that specific minute, and if it times out then you have to do it again. Or, you know, the new thing is there's a lot of issues with people buying stuff online, is where they go and buy something online using their bank card, and they have to, let's say Visa has to authenticate. So let's say you're buying, I don't know, a phone online, and you put in your details, and then Visa contacts your phone to say, or you put in your credit card details, you put in your expiry date and your CVV code at the back. But then also Visa will contact and send an app on your phone that says that you have to authenticate as well. So this is authentication. I am who I claim to be, and it's one of the most simplistic forms of security that you have, and it works because it is simplistic generally, you know. Okay, so the next one is authorization. So I am granted access to X amount of resources. I am allowed access whatever specific resources, you know, on the company. So who's authorized? Who is authorized to configure the router or the switches? Okay, you know, the clue is in the name itself. So authentication, authorization, you know. So when you log into a router, if you can get into the router, if you can do all the commands, if you can shut it down, well, that means that you have the correct authorization. Okay. And accountability creates an audit trail. A paper trail. So let's say, for example, we have Tom here, and he is logging in to router here. Okay, so he logs in, he's telling us in, he'll have his individual username and password. Name's Tom, my password is Tom PW. Okay. What this is used for, these suite of protocols, is AAA functionality, right? It's a centralized way of managing all your network devices within inside your company, okay? So it's used as a way of securing and controlling your access, your management access to your network devices. Okay, so when Tom logs into a router here, let's say R1. Now let's say we have a load of routers here. R2, R3, R4. This works on the premise that no individual details are stored on the actual routers. They're stored in a centralized device called an AA server or radius server. Okay. And this radius server has all the details stored on it once here. So you'll have, what did we say those 4 users were? Tom, Al, Bob, and Joe. They're all stored in this radius server. So when Tom logs into this router here, Tom's details are not, it's not stored in this router. So he puts in his username, password. The router there would send a message over to the radius server and say, I've got a user here called Tom, and his password is Tom PW. Does he have, is he who he claims to be? Is his password correct? And the radius server will perform authentication and will respond back to the R1 and say, yes, you can allow him in. So now Tom has access to make changes on R1. What else can this radius server provide? Well, it can do all three, like as I said. But what else can it do? It can, let's say, Tom is an intern, junior guy. Okay, so he only has, let's say, he's only beginner. So he's only got a beginner here. So when he logs into the router here, R1, he has limited commands that he can do. He can do show commands on R1. He can't configure anything on the router. He can't change anything on the router. He can only go into user mode and privilege mode. And even in privilege mode, there's only specific commands that he can do. He's not allowed to go into global configuration mode because that would give him a higher elevated access. So there you're putting your, so authorization is controlled by Tom's username and password. Authentication, should I say, is controlled by Tom's username and password. Authorization is where the radius server is saying, yes, you're allowed access to X specific amount of resources. Okay, now let's look at Joe here. So Joe logs into this router over here. Let's say this is R4. Now Joe is full-time staff, and he goes and he makes a change, and he brings down this router here. Well, there's going to be in the sys logs, and there's going to be a log of all Joe's details was sent to this radius server and will be stored again over here on this radius server, showing all the commands were typed in. So Joe can't turn around and he can't use, he can't say, oh, that wasn't me, because there's a paper trail of it. Okay, so is there any questions on that?
Nope. No.
So these three things are really used as you have a centralized device. And it means you can configure a whole company's network devices from one specific third-party server. There's two different types of services you can have. Radius is industry standard, while Cisco have their own called TACACS. Okay, but this one radius server is used to configure and manage all your other devices, regarding its routers or switches or both. Now somebody might say, well, okay, well, what happens, right? If all, let's say Tom, Al, Bob, and Joe's details are here. Is there any configuration to be done on the routers themselves? Yes. What you need to do is you need to create first of all, you need to specify where the server is. Okay, so let's say R1, you need to say, we have a server over here and its IP address. So on the radius server, you'll say, sorry, on the router here, you'll say the IP address of the radius server is, let's say, 1.1.1.1.1. So the router knows where to contact it. As well as that, you set up what's known as a key. You create a key. Okay, so you create a key. And let's say the key that you create is just a password. So it'll be the same on both the routers and the radius server. So let's say the key is called my key. Okay, you set that up on both. So when R1 contacts the radius server will say, hold on, well, how do I know even R1? How do I know that you're a trusted source? Well, the R1 is going to say, well, let's check our keys. My key is, or the key is my key. Now, it'll all be encrypted. And they'll check the hash of it to make sure that it's the same. And say, oh yeah, we can talk to each other. Our keys are the exact same. What happens in the event that the radius server or the server here goes offline? Think about it. If this radius server goes offline and the other devices can't contact the radius server, well, that means then that it's plausible that no one will be able to manage any of your devices. So what you should do is, and what you can do is, you can create an admin password, one admin password, which is used to connect in to these devices in the event that the radius server has gone offline. Okay, so let's say the admin password is pass W0 or D, something stupid, right? Now you never use that, right? And Tom tries to tell it into the router, and the router will contact the radius server. The radius server is on fire. So the router then will not accept Tom's username and password. Because the Tom's username and password is stored on this radius server. But Tom uses this admin password, and then he'll have access. Okay, this admin password will only work when the radius server has gone offline. Okay, you can only use the admin password on these routers or switches if the radius server is offline. So if the router can't contact the radius server, well, then it can use the admin password. If the router can contact the radius server, well, then they'll have to use the administrative passwords that is provided to them by the radius server.
Would it not defeat the purpose of having separate passwords if there is an admin password handed out? Like if someone left the company, they would still have the ability to type the admin password where necessary.
Yeah, but did you see that there's always going to be this sort of thing that, yeah, you know, there's always, like, usually you change the admin password every, you know, couple of months, and you just share it across with your network team. But there's just really nothing that can be done. Again, the admin password won't work unless the actual radius server has gone offline. So, you know, while it's a great idea to have the radius server, but there's a problem insofar as if you have one device being used for management of 50 routers and 50 switches, and that one key device goes down, well, then you need to have a sort of a bit of redundancy there in place to say, well, okay, what happens if the device goes down? We have to have a way, a backdoor way of getting in. Okay, I'll show it to you on Packet Tracer here now. Let me just open up Packet Tracer here. Okay, right. So we got a user PC here. We get a multi-layer switch. And we get the server here. So connect these in. For one, it isn't for a 3 here, right? Okay, so what we need to do is just give IP details. So this is 10.1.1.1, and change the mask 255.255.255.0. Default gateway is, let's say 10.1.1. Actually, I'm going to say change this to 20. This 10.1.1.5, and default gateway is 10.1.1.1. Okay, and this guy over here, just giving them IP addresses, is 10.1.1.8. 255, 255, 2550, 10.1.1.1. Cool. All right. All right. So what we're going to do is we're going to get it. So we're going to create a username. Let's say username is Tom. We'll create another few of them. Username is Tom, Bob, Joe. Tom, Bob, and Joe. Okay. Over there. Right. So I wanted to switch first. Let's see, the first thing we need to do. So what we're going to give this, where the IP address of this guy was, what? Let's put IP details in here. Excuse me, 10.1.1.5, 10.1.1.1, and 10.1.1.8. Yeah, cool. Okay, so we're going to switch. So turn it on, config switch T, AAA, new model. No. So you're setting this up. You say, I want to use AAA. And you can see them there, accounting, authorization, authentication. So AAA new model. That's just turning on the service, just enabling the service. Okay, so what I'm going to do now is the next one, I'm going to create a local username and password. Okay, so this is so this local username and password is to be created in the event that this Radius server here goes offline. Okay, so this is our Radius server. Okay, so we set it up here. So we'll say username local, password is local PW. Okay, so in the event that the switch can't contact the Radius server, Tom over here, or Bob or Joe, will still be able to access the switch by using the local username and password. The username is local, password is local PW. Okay. Now another thing, what we have to do with any switch is the username only gives you in straight away management access. It only gives you your first access. So it's always a good idea to create a password to go from user mode into privilege mode. Okay, so which is your enabled secret password or your enabled password. So say enabled secret, and that password is my CISCO. Okay, this is not used by the Radius server. This is used just so you can go from user mode into privilege mode. You're not setting that up on the Radius server here. Okay, is that okay, guys? Any questions on that?
That's all good.
All good.
Cool. Thanks for that. All right, so the next thing is now here's where we're going to be configuring our switch to talk with this Radius server. Or actually, I'm going to say it's TACAX. Okay, so okay, so we're going to say we want to set up AA authentication, and we want to use. We're going to set up authentication lists. We'll say login. We need to use a group, okay, and we're just giving this name of our list. We just we call it my auth. It's just a list. The group that we're going to use, which will be also the same group on the server, will be TACAX. And in the event that the local server is offline, we can go default back to that. Okay, so you're saying that we want to set up authentication. Our login list will be synced with the list over here and the TACAX server. And in the event that the TACAX server goes offline, then default back to our username, our local username and local password. Okay, we also need to set up a key, which the key will be created on the switch, but the key will also be created on the TACAX server. Okay, so let's say TACAX server host 10.1.1.8, wasn't it? Which is the IP address of the TACAX server, 10.1.1.8. The key we're going to create is called my key. Now the thing is that key there called my key will also have to match on the TACAC server down here. Now, one thing that we haven't done yet is we haven't given the switch an IP address, a management IP address. So we're going to do that now. Excuse me. I'm really bunged up today. Sorry about that. Okay, so we'll say interface VLAN space 1 IP address 10.1.1.1, yeah, 255.255.255.0, and no shutdown. Exit. One more thing we need to do. We're after giving the switch a management IP address. We still need to go into the management port on the switch and configure, tell the switch to use that TACAC server list called myauth for authentication. You do that in line VTY 0 space 4. So you say login. By the way, you don't need to know these commands. Authentication, and the name of the group was myauth. Okay, that's done on the switch. Okay, now we're going to go into the server down here. And our services, go to AAA. Okay, we just want to enable it over here. The service type, we'll say is TACAC. The client name, we'll just call it. So we'll add one in. Okay. Okay, so we'll say client name is switch. The IP address was what? 10.1.1.1, which is the IP address of the switch. Okay, so in this case, we were having this is a client server configuration. The server obviously is the TACAC server, but the client is the switch. And this key, this secret is my key. And okay, so switch 10.1.1.1, my key, and TACAC server. Okay. And
If you have multiple switches or routers, you just add line by line, is it?
Yes, exactly. Yeah. Now you can program this all. Like, I mean, there is quite a bit of work here to do this. But what we'll talk about next week is, you can run scripts that will take all of this information and log into the devices and run this script and then log out again, with Python scripts. Okay. So the last thing we need to do is create our username and passwords. So we'll say username is Tom, password is TomPW. Add username is, was it Bob? Password is Bob PW. Add username is Joe. Password is Joe PW. And there's a lot more you can do in this. It's just really just touching off it. Again, you can set up two-factor authentication or MFA, multiple factor authentication. You can configure, you can force your users to have complex passwords. They must be 12 characters long, and they must have all these strong signals and symbols and everything like that. And what else you can do is you can force your Tom and Joe and Bob to change your password every 2 or 3 months. And it can't use the previous 10 passwords. Anybody who works in the corporate environment is well used to doing this stuff. What I do as well is just a side topic. Let me see if I can get this. If you find it very hard to manage all your passwords, there's a great app called KeyPass. It's free, and you just install it. It's there. Basically, you install it and you'll have all your passwords on this one application. And then you just create one long password, and that's the one password you need to remember, which is to get into KeePass. So you don't need, you could have 50 passwords in KeePass and you don't have to remember any of those passwords. You just have one long, strong password that you need to know, and that will be for management of your KeePass. Okay, it's really, really useful. A lot of companies will use this. There's lots of different ones. That's free as well. And it is very secure. Okay. So that's that done there. Let's check it out. Let's test it. I hope I haven't forgotten anything. All right. So let's say Tom here tries to tan it in. So we say tan. Let's see if we can ping it first. Ping 10.1.1.1. Okay, it's responded. That's good. Okay, can I tell it into telnet 10.1.1.1? Okay, username. Okay, so it's asking for username. Username is Tom. Password is Tom PW. There, I'm on the switch. I don't have Tom. Like if I exit out of this and do show run, there's nothing there that has Tom's username and password there. Tom's username and password details are stored centrally over here on this TACX server. Okay, so he puts in his username, Tom, his password Tom PW, and then he's in user mode, and then he types enable, and the switch is asking for his password, which was my CISCO. Now, my CISCO is stored on the local end switch. Yeah. So that was stored locally in the switch. But the initial connectivity, the initial connection was Tom getting onto the switch. Tom's details is over here, stored in this TACX server. Okay. So I exit out. Try connecting again. Username is Bob PW. One sec, try it again. BOB. Bob is, yeah. Was it Joe? JOB. JOB. Yeah, that works. Okay. What I might do is I might go in here and I'm going to shut down here. I'm going to shut down this TACX server. Okay. So, or I'll shut down this link here. 1 second. Show IP in brief. I think it was FA0/3. Yeah. Okay. So click space T, copy space T, interface FA0/3. Okay, so you can see the connections down. All right, so now we try and connect in to the switch. So 10.10.1.1, connect in. Username is Joe, password is Joe PW. It's not going to work, is it? Because Joe, the switch here doesn't have Joe PW stored locally, and it cannot contact the TACX server because the TACX server is down. So in this case, we will need to default back to the local username and password, which was username was local and the local password was LOCA. Back in again, LOCALPW. This local username and local password is only to be used in the event that the TACX server is gone offline. Oh, that didn't work. 1 second. LOCALPW. Ah, we're in this time. Okay, cool. Oh, my Cisco. Okay, any questions on that, guys?
Nope.
If I enable
That's
this
good.
again, backspace T, interface FA063, no shutdown. Now I'll go back in. Let's try the local username and password when the TACAC server is online. LOCAL, password is LOCAL PW. Won't work. Straight away logging invalid because the switch says no, I can contact the TACAC server. This local username, this local password is only to be used in the event that the TACAC server is gone off. Okay. So this is really for use to be used. It's you know, the service is to be used for management of all your key network devices. It also can be synced in with Active Directory. So you can have the same username and passwords that you do to log into your routers as you do to log into your laptop. So you can sync up TACACS and Radius with Active Directory. Okay. Just give me 1 second, guys. I'm just going to just pause it for a second. I want to go down there. I'm going to turn on the heat. It's pretty cold up here in the room. Just be 1 second. 1 moment. Right. Let's see where we are in this. 1 moment. Okay, let's say we have a link to the internet, right? This fluffy white cloud is the internet. Okay. Internet. And we have fluffy white cloud is the internet. And we got a router here. It's here. And let's say we have a web server here, okay? And our web server is selling phones, okay? So we have a phone website called phone.ie, all right? And let's say we have a public IP address of 3.3.3.3. Okay, so usually when a company has an internet connection, all right, usually the majority of times that internet connection serves traffic going from the company out to the internet. For the example of your browsing. So if Tom over here is browsing, he's going to, the connections are normally initiated from the company here out to the internet. If he's checking his emails, he's going back out to the internet. Okay, so typically it's going to be all this way. But in this case here, where we have a web server, the most important traffic is really, we want the internet to come to us, because we have a business page. We have a web server, phone.ie, and we have a website attached off that web server. So in this case, we need the internet to come to us. Okay. And I will talk about DNS and stuff like that next week or in a couple of weeks' time. So let's say, for example, we have, let's say 100 meg link, 100 megabits connection. And this link is by Sky. Sky is our ISP. And this connection goes offline on Friday evening at, let's say, 9 o'clock at night. Okay. And we're a Monday to Friday company. We log in. There's no alert set up. We don't have any alert set up on our company. And it might be plausible that the next time somebody knows that this link has gone down, could be Monday morning. What's happened? Well, basically, there has been no phones sold in our company for the last, for 48 hours, which will mean a drop in revenue. People are going to won't be able to get paid. We've suffered irrevocable damage for our company because people aren't going to go on phone.ie if the website is down. They're never going to go to it again and say, Jesus, this is a company. How can we trust a company that sells phones and it's offline half the time? Okay. So I'm really exaggerating this, by the way. Typically, years ago, this might have been the case, is that if you had a website, you'd have to house it internally, and you'd have to have a comms room and stuff like that. But nowadays, you're going to use, you're going to use cloud computing. You're going to use AWS or Google Cloud or Microsoft Azure or something that to host it for a fraction of the cost that it would to do it yourself. But there is still definitely a benefit to monitoring and managing all your key devices, so that if something like this connection to the internet goes down, well, you will, or the on-call guy will get some sort of a notification to say that link has gone down. Okay. And one of the main tools for monitoring and managing all your key devices is called SNMP. Okay, SNMP stands for Simple Network Management Protocol. What I might do is I might get rid of this switch here. Obviously, there's a switch there. I'm just going to, just for this purpose of keeping things nice and tidy, Simple Network Management Protocol. Okay. Simple Network Management Protocol, and it is used to manage all your key devices. It's not just used for routers. It can be used for, literally anything that has an IP address can be monitored by using SNMP. Usually you have a couple of different things. You've got your SNMP manager, which is like a server. You've got an SNMP agent. So this is your SNMP manager here. And again, this is a third-party piece of software that is used to monitor and manage your devices. Okay, you've got an SNMP agent, which is your router again in this case, because it is being monitored by your server by your SNMP manager. Okay. So SNMP can be used to monitor anything, any statistic that can be generated by a device can be monitored by SNMP every time. And if you want to think of what do we mean by statistic, you can monitor, let's say we can monitor uptime. You can monitor OSPF neighbors. If a neighbor drops, you can monitor CPU. You can monitor temperature. You can monitor traffic going in, ingress traffic, and egress traffic going out. Disk space on your devices, disk space on your routers. All of this stuff can be monitored by SNMP and can be tracked by SNMP. And it's not just routers, it's literally anything that an IP address can be monitored. So you can monitor your routers, you can monitor your servers, you can monitor your phones, you can monitor switches, you can monitor IP phones, telecom phones, you monitor laptops, desktops, everything using SNMP. Okay. How it works is that this is just some of the things that what else? Even an interface. So all your interfaces on your router can be monitored. So let's say interfaces. Interface FA0/0. Okay. So let's say we have an interface over here on this router, and this is interface FA0/0. Which is our link to the internet. Our SNMP manager will create a database of questions that it can ask the SNMP agent, okay? And each question is called an OID, an object identifier, okay? So you can have an OID, for example, about interface FA0/0. And an OID works it's like a backwards IP address. It looks like something like this: 0.1.3.4.6.2 or .7. Something like that. Okay. And that will be stored on the SNMP manager, but it'll also be stored on the router over here. And the SNMP manager is constantly polling, constantly contacting the router to obtain information. And these questions that it asks is called get. It'll send SNMP get, okay? So the SNMP manager will send an SNMP get, and it'll say, I want to get information of 0.1.3.4.5.7. Can you provide me with that information? That SNMP get will be sent from the SNMP manager all the way across to the agent, and the agent will then look and go, 0.13457. Oh, well, that is pertaining to my interface 0/0. So the router then will respond back with information about 0.13457, which is FA0/0. And the SNMP then will log it and track it and keep a log on it. Okay, so these get messages are used or are sent by the SNMP manager to retrieve information from the routers, such as the uptime, any OSPF neighbors, any CPU, any temperature, what's the traffic going in, what's the traffic going out, literally anything. Okay. So it's a poly thing, and let's say it's sent every 2 minutes. So we're contacting, or the SNMP server is contacting the router, looking for information on FA0/0. And it's sent every 2 minutes. But let's say something happens, this link goes down. If this link goes down, we can't wait for 2 minutes for the next time the SNMP manager contacts the router. So what we can do is you can configure the router in the event that this link goes down, or in an emergency where the router will notify the SNMP manager by sending an SNMP trap message. SNMP trap. And basically this is a warning from the router to the SNMP manager to say, shit has just gone down. A link has gone down. The CPU usage has gone high. The OSPF neighbor has dropped. Our traffic has gone to 100%. We're going to be dropping packets because there's too much packets coming in. Okay. So normal operations, it's the SNMP server is contacting the router by using SNMP get message. The connections are initiated by the SNMP manager. However, in the event of an extraordinary event, then the router can contact the SNMP manager by sending an SNMP trap message. Okay, and you can set up alerts. So what you could do is, yes, your CPU normally is 40%. So this is your router's CPU never goes really above 40%. So you're going to say, well, I want to configure my router that if the CPU goes to 60%, well, then the router is going to send an SNMP trap to the SNMP server to say, look, the CPU has gone to 60%. I'm letting you know. And what can the SNMP server do? Well, again, you can have built in an on-call system or an alerting system where this can text or email or ring, even an automated thing, to ring a predefined number, 087-111-111-111. And you get a call at 3 o'clock in the morning from your SNMP manager to say that the CPU has gone up to 70 or 80%, or the link FA0/0 has gone down. Is that okay? Any questions on that? So you see the difference between the SNMP get message and the SNMP trap.
Mm-hmm.
Get messages are polled every couple of minutes, and they're looking to retrieve information, and it will be stored on the SNMP server. And trap messages are initiated from the SNMP agents, which are the routers, which will inform the SNMP manager if there's a significant event. Okay. Another thing is these now I want to just kind of clear up some of this chicken scratch here. This SNMP get messages. They are read only. Okay, so they're read only. So the SNMP server can only look and inspect the information given to it. Can't do anything with it. But you have a more powerful tool called an SNMP set message, where if you authorize the SNMP server manager here, it can change information. SNMP is a really powerful tool. So a set message is sent by the SNMP manager to configure or to write to the SNMP agent. So you could use a set message to delete an OSPF neighbor or to shut down an interface. Lots and lots of stuff you can do here. And we'll see that I'll do a display on it where you can see that going, where you can see that happening. Okay. Is there any questions on that, guys? No. Okay, cool.
No, that's good. Thanks.
Right, let me just. So because you can use these set messages and get messages, you also have 3 different versions of SNMP, and that all depends on sort of, well, I'll go through. So you have SNMP version 1, which is old. You shouldn't use it. It's old. It's gone. Okay, SNMP version 2. You call it 2C, and this brings in security based on community strings. And a community string is like a password. Okay, so basically what will happen is that you will set up a community string on the SNMP manager, and that community string also has to match the SNMP agent. So it's just a long text file. It's like a sentence. Okay. Now the problem is it's just really a clear text password without encryption. You've got 2 different types of community strings. You got a read-only community string, which is for your get messages, and then you've got a read-write, which means you can use your set messages. So you've got a read-only and a read-write. So again, highly powerful thing. If you can think, like, you could use a community string, or you could use your SNMP server to bring down key network devices by using your read-write community strings. And the last one there we have is SNMP version 3. Okay, and this is where a lot of security that we have in here. Okay, so SNMP version 3 brings in what's known as integrity. And integrity means that packets, SNMP packets, have not been changed during transit. Okay, so what that means is that we can't have someone up here. So let's say the management, let's say the IP address of this SNMP server is 192.168.1.5, right? And let's say this is 1.1. You could have somebody here doing a man-in-the-middle attack. And taking your SNMP packets and sending them across to the agent and saying the SNMP IP address is 192.168.1.3, which is it. So a MIM attack or man-in-the-middle attack is telling the router over here is changing the source address of the SNMP packets to be not 1.5 but 1.3. So then the router then doesn't respond to the SNMP manager, it responds to this guy over here, and he collects information. So SNMP version 3 is configured to stop that from happening. So it won't be able to, you can't change packets as it passes from the manager across to the router. Okay. You have authentication. Which means SNMP packets are coming from a valid source. Yeah, we go back to this, I am who I claim to be. So it uses hashing algorithm to ensure the validity of the actual SNMP server. And the last one then you have is encryption or privacy. Encryption. So packets are encrypted during transit. So no one can see what the SNMP, again, man in the middle attack, he can't do anything with it. If he listens in on the traffic going across, it's only going to come up as gobbledygook. Okay, so there, SNMP, these are 3 different versions. SNMP 1, no security at all. SNMP version 2, limited security based on these community strings that we're talking about. And SNMP version 3, which is all about security. It provides integrity, authentication, and privacy. Okay.
Are they on all hardware, those 3 versions of SNMP, or is it hardware restricted, like only newer hardware would have certain?
Nowadays, with anything, any devices that were manufactured in the last 10 years will support all 3 of them.
Cool.
Yeah, so yeah, and you have to just say which one you want to use. But yeah, one would be you won't use one. It's dogs years old. Like you're going back to like the 80s, so you know you wouldn't use it. Okay, let me just show you it in Packet Tracer. Now by the way, SNMP is very GUI based. Actually, what I'll do is before I do that in Packet Tracer, I'll see if I can show it to you online. It's all very GUI based. So the front end, what the network guys will see is it's all be a GUI based, you HTTP onto it. And you'll be able to do graphs and reports, and you'll be able to send on the information over to your manager and stuff like that. So it is really, really user friendly. And again, it's a no-brainer. If you have a lot of devices in your company, then it really is, you should use SNMP. Okay. So let me just there is a company called Observium, and they used to have a live demo. They still have a. Oh, there you go. The username and password is demo and demo. Ah, cool. So you can see in here. This is what it looks like. So you can see demo packets. You can go on all your devices. You got servers, you got workstations, something that's down there. And again, it uses the colors a lot. So green is good, orange is it's past its threshold, and red is not good. It's down. So you can see here, devices changed it down. This device here has gone down. So let's say all devices here. And what are you monitoring? There's just some Windows. Oh my God, NT. God, it's been up for the last two years. Really, like this Observium thing, they really should get this better done. They're giving a demo to people to try and sell their product. You would think that they could, make it a little bit better for people to see. But like you can see, this is some sort of device over in Germany, and you can see the packets coming in, the packets going out. You can see the day stamp here as well. Total device traffic in bits per second. So again, you can say I want a report of the last 3 months of the packets coming in and out in bits per second. Oh, speaking about China. See stuff in there. It's really, really useful. And can be done a lot on it. And there's massive companies, you know, there's companies that spend tens of thousands of euros setting up SNMP on their devices to make sure everything is responding, you know, to it. Some of the large companies that will use it will be Solar Winds. They'll be quite big one. They've been based down in Cork. You got Nagios, you got Cacti, you got Big Brother, you got Wavefront. See, this one here is Observium. You got Ops Manager. Tons and tons of SNMP tools that you can use. Okay, I can show you this in Packet Tracer, which will give you a brief glimpse of what you can do with SNMP. Again, this is just a kind of Packet Tracer. This will introduce you to your OIDs. By the way, I mentioned this earlier on. Your OIDs, okay, is an object identifier, which is basically one statistic. Your database, which is all of your OIDs, all of your statistics put together, is called a MIB. And a MIB stands for Management Information Base, not Men in Black. Okay, so earlier on when I said we had CPU, fan, disk storage, temperature, interface, traffic going in, traffic going out, all of those are specific OIDs. But all of those OIDs put together is called a MIB, Management Information Base. So it's a MIB is like a database of statistics. Each individual statistic, one statistic is an OID, which is your object identifier. For example, you might have an OID for your CPU. It would be looking something like this: 0.1.3.2.4. It's like a backwards IP address. And there's a sort of a parent structure that it follows, like a directory that it follows. We don't need to know any of this stuff. Okay. Okay, so let's see. I'll show you in Packet Tracer. Where are we? Here we go. Cool. So we just get a server over here. And we get a router. Say 1941. Actually, I think this guy here has to be PC. I think this PC is your SNMP, or for some reason. So let me just configure this here. So I'll say no, enable config space T, interface gig 0/0, no, shut down, host namespace Dublin, host namespace Dublin. Okay. So go in here, give this an IP address 192.168.1.5, default gateway 192.168.1.1. Okay. Let's see if I can ping it. Ping 192.168.1.1. Now, what did I do wrong there? 192.168.1.5. The router. I didn't give it an IP address. Interface by state interface gig 0/0, IP address 192.168.1.1. interface there. All right. Okay. So when I set up SNMP, how do you set up SNMP? Well, you go into your router first. So config space T, SNMP, and you create your community string. So we say SNMP server community string, and we give our word. So this is like your password. So we'll say com or o. Okay, that's my password. And this is my password, and this is going to be for read only. So this will, if my PC has the same key or community string as the router in Dublin, then then we can perform read only messages. We can send get messages to the router, and we can obtain information from it. So that's your read only community string, but you also can use a read write community string. And that means that our SNMP server over here can change information about the router using the read write access. Okay. So we go over here, we go to SNMP MIB browser. Okay, we put in the IP address. Okay, so it's 192.168.1.1. This is the IP address of our router that we want to get information about. Click on advanced. Our community string was what? Com or O and com or W. Change this SNMP version 3. Click on OK. And see this you have here. This is your MIB, SNMP MIB, Management Information Base. Okay. And these are your directory structure. So move this across. So, oh, here we go. So if I want to get information of how long this router is up, you can see there's a specific OID just for the uptime, which is 01361211130. Okay. So I'll use that. I want to find out how long this router is up. I'll use that OID, which is here, and I will send a get message to it. Here we go. I'm just after sending a get message to the router, and the router is after responding back and is saying, hey, I'm up 4 minutes. The router told me that. Okay. Now again, this is very sort of, you know, like you've seen from Observium how GUI based it all is. So I just wanted to show you, like, you never see this, it'll never be this bad of an interface. I want to find out the system name. Again, get message. It's responding back and saying Dublin. Now here's a question. Can I use the set message to change the system uptime?
I'd say no.
No, you can't. Because the router is up for the last 5 minutes and 23 seconds. You can't change something that can't be changed. You know, this is a piece of information. The router saying, well, yeah, I'm up for the last. So you can't go in there and say, no, you're not. You're up for 16 hours. The router say, no, I'm not. So you can't change that. So the set message can be used for things that can be changed. Like if your CPU, for example, is at 20%, you can't use the set message to change your CPU utilization to 50% because your processor is only running at 20%. I hope that makes sense. So can you use it for your system name, your host name? Yes. I can change my host name on my router. Now there's a few things I need to do here. I need to change this to octet string. And I can change the system name by using a set message. set is to change it, and I'm going to change the router to SNMP underscore test. Okay, and then click and go. Oh, there we go. So I've used the set message on this app to change the host name of the router. It was Dublin, and now it's SNMP test. Let's click on this. Looks like it's Dublin, but if I press enter, you can see it's changed from Dublin to SNMP test. Okay, so all of these key you can interfaces. So you can get a list of your tables. Now I don't know how much stuff that we could. There we go. Some of the stuff, your numbers. Oh. You can run OSPF and stuff. You know, it's really much more clear on how to do it on a GUI base. You know, GUI, it's like next, and to configure SNMP in using SolarWinds or Servium. It's really self-explanatory. It's much easier than doing this in Packet Tracer. All right. Any questions on that, guys?
No.
No.
Okay, cool.
Jerry, is the software expensive?
Yes. Very.
Okay.
Yeah, it is. To be honest, it is expensive. What they might typically do is they'll give you a trial, where you're allowed to poll 1 or 2 devices, and they'll set everything up for you, and it's licensed. It's usually licensed. It's usually license based as well. So you'll have to renew your license every year, and it'll cost money to do that even. But what they'll do is as well, like let's say someone SolarWinds, they'll set up a WebEx or something like that, or Zoom, and they'll go through configuring all your stuff for you. They want to set it up all for you, and so when it's working and works really, really well, and then it makes it makes it harder for you as a company not to use it, because you really get a lot out of it. You know, if you think about it, what it'll do is it'll give you a one glance view of all your devices on a GUI base. You can run reports that you could never do without it. You know, you can run spreadsheets, you can do PDFs, you can export it across. You know, managers love it, because, you know, managers love all these pretty pictures and graphs and pie charts and, you know, things like that, uptime and everything.
Thank you.
So there's an example there of your SNMP3 there. So it starts off, you know, you've got all these structures. It's just like a backwards IP address, like I said. And yeah, you can. So that website there is, I'll just put it into chat there. It's Servium, and you can just. It's worth your while just to go into it. 1 second. You can get a demo of it. So that's it there, Servium demo. So just click on live demo, and can I exit log out there. So log out. Your username is demo, and your password is demo. So you can see it here. Log in there. What I'll do is put that here, and I'll put that in chat. What's wrong with this chat? Here we go. Cool. So your username is demo, and password is demo. Cool. All right, guys. It's half. We'll take 15 and come back to quarter. Yeah.
Grand.
Cheers.
Cool.
Thanks,
See you
guys.
then.
Okay, see you. Bye. See you in what?
Yeah.
Yeah, all good.
Okay, cool. Just load all this here. Right. Visual cards, there we go. Right. I shouldn't have got rid of that that router there I had running. So I just need to go back in here and configure it really quick. So I'm going to try to stay on the central theme of network management, of using third-party pieces of software to manage our network devices, our key network devices. So we looked at AAA, which is used for your access, that your network engineers, your IT staff will use AAA to log in, to telnet in, or SSH into your key network devices. SNMP is used to monitor and manage your key devices, or any device that you have on in your company. Gig 0/0 IP address 192.168.1.1 255.255.255.255.0. No shutdown. Okay, there's a router there. Let me just log on to here. Crossover. Not that it matters, but you know, just be pedantic. 192.168.1.5. 192. What was wrong with that? 192.168.1.5 and Jesus. 255.255.255.0. 192.168.1.1. Sometimes I just gotta slow down. Because I'm making too many mistakes. Okay, so we got my router here. I got my laptop, and oh, that's what I wanted to see. So see these guys here. You got sys5 config, link 5 config, line proto 5 up down. These are messages that are generated by your router to indicate that there's been an event. Now, these are not SNMP messages. These are called syslog messages, system log messages, okay? And these system log messages can be stored locally. So you can store these syslog messages locally on the router. In the device's NVRAM, actually not NVRAM, RAM. And I'll talk, RAM is random access memory. Now, we will talk in a few weeks' time about file management. But the issue with RAM, okay, random access memory, any type of RAM, is that any content stored in RAM is temporary. So your device loses power and has to boot up or whatever, everything that is in RAM is gone, okay? It's sometimes known as volatile or temporal, yeah? RAM. So your system log messages that basically when an event happens, if it's stored locally, you can see what happens. You can look at the messages by doing like a show log or show logging. But you only see messages up until that router was turned on. So if you have a problem with your router, let's say your router goes offline or shuts down or reboots for some unknown reason. Well, you can't log into your router if your router reboots unexpectedly to find out what happened, because your router is rebooted, and as a consequence of that router rebooting, then any messages that were stored locally in the RAM are gone. So it's always a good idea to have a syslog server. That your router will send any of your event messages, and they're only just messages, they're only sentences, over to the syslog server, which will be stored in a disk for as long as we want. And these will be stored, you know, for months or, you know, years or whatever. Usually, if it's only syslog messages, maybe you might have 6 months storage. So you want to find out. So if we go back to this, like this router, okay, it looks, there's something happening with it. It's sending a load of messages, and then it just shuts down and reboots. Okay, the message that I've sent, it can't be accessed locally because everything that is sent to RAM is lost. Any info that is sent to RAM is lost. However, you can log on. This guy here, logging onto the syslog server, and he can look at the last messages that were obtained for, or that were generated by this router before it went to shut down. Okay. So let's have a look. Do we need to do this? I think actually this is done on a server. We need a syslog server. Yeah, 1 second. It's a syslog server we use. So let's get rid of this guy here. Delete this laptop, yeah. There's very little to syslog. There's one thing you need to remember, and I'll go through it now. 192.168.1.5. Okay. Okay, so you can see all these messages coming in. You have 8 different types of messages that come up depending on the numbers. Okay, they're labeled from 0 to 7. 0 to 7, which gives you 8 different types of messages. Now, I would say you need to know these. Let me open this with Paint, because there has been questions come up like this before. So these are these severity levels are matched. So if you have a look at here, okay, this is saying line protocol 5. So this 5 here is matched with notification. It's a notification message. How do we know that? Because the 5 tells us so. Okay, the more severe your message, the lower the number. Okay, so the more severe the message that is generated by your device, the lower the number. So you got 0, 1, 2, 3, 4, 5, 6, and 7. Okay, so emergencies, alerts, errors, emergencies, alerts, critical, error, warning, notification, information, debugging. Okay, now you do need to know that there is a mnemonic that will help you put them in the right order. Okay, and the mnemonic is, oh, a sec. Every alley cat eats watery noodles in Dublin. EACEWNID. Every alley cat eats watery noodles in Dublin. If you just remember that one sentence, every alley cat eats watery noodles in Dublin, you know, you can nearly pick the type of alert, the severity. emergencies, alerts, criticals, errors, warnings, notifications, information, debugging. Okay, and that goes from 0, 1, 2, 3, 4, 5, 6, and 7. Okay, you will need to know that for your exam. So let's say, for example, if we configure this device over here, right? If we configure, you can configure your router not to send all alerts over to your syslog server. You don't want all of your alerts being sent over to the syslog server. Why? Because it's just going to jam up. If you've got 50 devices here, all sending alerts over to the syslog server, and they're needlessly. So what you can do is you can set something like logging trap 4. And what will that send? So if you use that command, logging trap 4, on your router, that will basically send all level 4 messages. Now this is very important. All level 4 messages, but also everything that is more severe than level 4. So logging trap 4 will send level 0, 1, 2, 3, and 4 over to your syslog server. Does that make sense? If you say logging trap 7, it's going to send everything. This has come up in an exam time and time again, where it will give you it will give you something like logging trap 2. And then it'll ask you what type of alerts are generated, what type of alerts are logged by this server over here. And in that case, it would be always, if logging trap 2, it would be, you've got 3 alerts. You've got emergencies, you got alerts, and you got critical. Okay, installation of it is very easy, guys. You have this an IP address already. So you go in here, config space T, change the host name. Dublin, logging server, or logging host, 192.168.1.5. Logging trap, debugging. There, and you can say that we've already sent, we're now going to be logging to this device here, 192.168.1.5. They're only messages, they're only text messages. Text messages are sent from the router across to the syslog server. It's sending it over port 514, okay, UDP. So if you have a firewall in the middle here, you're going to have to allow port 514 through from this router across to the syslog server. Okay, so go into my syslog server here. Let me see, where am I here? Services even. Syslog. Oh, nothing has happened yet. So config is T logging 192.168.1.5. Find interface gig 0/1 shutdown. No, shutdown. Something should be in there now. Ah, there we go. Look, okay, cool. All right, now one of the things is wrong here is that what? You got your host name. You got your message, you have to click on the message, and you can see the syslog message. The GUI is not very, it's not great. But what are we missing? There's no point in you having a syslog message created when you don't have any time. So what you can do is you can you need to set up what's known as timestamps. And you do it on the router here. So basically you want to set up timestamps. So when a message comes in, when the router generates a message, it will also have a timestamp to indicate what time did, for example, this message occur at. So you have to set it up. So say config space T, service. Again, you don't need to know these commands. Timestamp, log, date time, millisecond. So that just basically adds a time and a date up to when this message was generated. So what I want to do now is I want to manually generate. There we go. We have manually generated this message here, or I go back in again, config space T into gig 0/1 shut down. No, shut down. So you can see all these messages coming in now. I'm going to my syslog server, and you can see the timestamp. Oh, what did we just? What's wrong? Look at the date and time. Look at the year. 3rd of March, 1993. Right? We're very, very. Probably guys in this class weren't even born. 1993. Jesus. Yeah. So okay, 1st of March 1993. Something's wrong there. Okay. So it kind of actually gracefully leads me on to the next topic, which is having all of your key devices, their time stamped to be matching the exact same. Okay. So, and this service is called NTP. NTP stands for Network Time Protocol. Okay. So basically what will happen is all your devices will automatically keep their time, their date in sync. Like think about it, years ago, you had to do this manually. You know, when the clocks went forward or when the clocks went back. This would actually cause a lot of problems on your network years ago when the clocks would go forward and would go back. Or because routers would not automatically generate. And it used to give issues in terms of OSPF neighbors would shut down, and there'd be a lot of stuff that would go offline. And what would nearly be worse is that some of your network devices would change automatically, and then some devices wouldn't change automatically. So it is always a good idea to keep the time across all of your devices in sync. And the protocol that does that is called NTP. Network Time Protocol. Think about it, your mobile phone has it. Last week, what did we do? We set our clocks, or the time went forward an hour. We woke up and the time was forward. We didn't do anything on a phone. Because your Windows, your desktop PCs are set to automatically get the time from an NTP server. Let's see it here. Alarm, world clock. Oh, settings. Let's see if we got this time settings. Settings. No, 1 second. System time. Change date and time. Here we go. Yeah, here we go. Change the date and time. Synchronize your clock. Okay, so you can see here. This time server is times.windows.com. So that's an NTP server, and that automatically syncs. It was last synced at 13 minutes past 8 or 6 on 2 days ago. Yeah, that just keeps everything in sync. Okay, and how it'll work is that you'll have your devices here, and let's say you have the internet. Okay. Have the internet over here, right? So fluffy white cloud is the internet. You'll have an NTP server here online. Like Google have their own ones. 8888 is in the NTP server. Or time.windows.com. And one router will contact your NTP server. Sorry, your router here will contact the NTP server that's in the cloud, get the time, and then all of your other downstream routers will contact that router there. All of your key network devices will contact this one router here to get the time. Okay, so it's not a good idea, for example, to have 50 routers all go off to the cloud. You don't need that. You just need to have R1 in this case. Contact the NTP server up here, get the time, and then all of your downstream devices, or 2 or 3 or 4, they contact R1 and say, what time is it? So again, you'd have to open up a firewall. Think about it. Does NTP, do you think it is TCP or UDP?
TCP.
Well,
Because UDP is undependable, isn't it?
so TCP is not, yeah, so you're right, yes. But what, so TCP means that anything that is lost or is corrupt gets resent. So let's say, for example, our NTP server told the clock that it was 8 o'clock at night and it was in milliseconds and it was 0000000, okay? And that then hit the router and that didn't get there, okay? So the router says, can you repeat that message? Like a second later, right? And oh, and the NTP server would say, oh yeah, it's 8 o'clock 00000, because the NTP server is repeating the exact same message that was lost, the packet that was lost. But now the time isn't 080000. The time is 08000010 or something like that. So NTP is UDP. UDP covers real-time traffic. Anything that's happening now is covered by UDP right now. And time is always happening right now. Does that make sense? In fact, the port numbers that NTP uses is UDP port 1, 2, 3. UDP port 1, 2, 3. That's the service that runs off that. So if you had a firewall between R1 and the cloud, the internet, you would have to allow UDP 1, 2, 3 through to the internet. Otherwise, it wouldn't sync. All right. So you can set this up again. What you can do is here. Now, I think there is issues on packet tracer. I've seen this before. You can, what was this? Or done. This can act as an NTP server. Okay, so this is, yeah. So this is my my syslog server can also be an NTP server. So it's 10 minutes past 9. Yeah. So I can contact the router to get the time from the NTP server. Fixed by C, NTP, and IP address is NTP server 192.168.1.5. I don't think this works with packet tracer for some reason. So show clock. Yeah, it doesn't work. Just, yeah, I've seen this before. So I've asked the Dublin router. I said, hey, the NTP server that you should be getting the time off is 192.168.1.5, and that should work. But it doesn't for some reason on this router. The servers, yeah. So, but don't worry about it. Okay, so that's NTP and syslog. Okay. All right. Right. Anything there? The only thing really I'd say, oh yeah, but syslog. So we just go back on this. Syslog captures key status messages from Cisco devices. You know, it's better off that you store them on a remote server rather than locally. And syslog uses UDP port 514. If you have devices, if you have routers and switches, and you wanted to build a lab, there's a free program called Kiwi syslog server, Kiwi, KIWI, and that's free. And you can send your router, tell your router to send. That's it actually there. You can see it there in the background. You can tell your router to send all these log messages over to Kiwi. And it's very simple. It's just a piece of text. It's a lot more simplistic than SNMP, because all syslog is doing is just capturing status messages. That's it. Text files. Okay. Okay. There's one more thing I want to talk about. I'm just going to build up, show this lab here. Second. Okay. Right. I might just do this from scratch and just talk about it as I'm doing it from scratch. Okay. So what I want to do is I want to get a router here. Okay. So I just create a 1941 router. Okay. It's going to be R1, and I'm going to have R2 here, and I have R3 here. Okay. So you're going to be R1. You're going to be R2. You're going to be R3. Right. Okay. And I'm going to have a connection between R1 and R2. It'll be gig 0/0 to gig 0/0. R1 to R3 will be gig 0/1. Let's say to gig 0/1 here. Okay. So gig 0/0, gig 0/1. All right. Now I want to set up a network between R1 to R3 and between R1 to R2. Okay. So the way I'm going to set it up is I'm going to use this network here: 192.168.12.0 and 192.168.23. Sorry, 13.0. Okay, so you see where I'm getting the 12.0 from. 12.0 is the network that connects R1 to R2, because the third octet is 1.2. The third octet here is 1.3, so therefore it connects R1 to R3. Okay. Now I just need to briefly just go and move these across a bit. So let's say no, enable fixed by C. So I'll say interface gig 0/0 IP address 192.168.12.1 255.255.255.0. So no shutdown. Okay, and then interface gig 0/1 IP address 192.168.13.1 255.255.255.0. No shutdown. Okay, so I'm going to just put in IP address beside this. So gig 0/0 is 12.1 and gig 13.0 our gig 0/1 is 13.1. Okay. Any questions on that, guys? You're probably going, why? What the hell am I doing here with this? I want to kind of, this is the easiest way I want to kind of just show you what I want to discuss next. So I want to put a loopback address on R2, and I'm going to use 1.1.1.1 on R2, okay? And I'm going to save the exact same IP address hanging off R3, 1111, okay? So I want to look at how a router will send traffic to an IP address if the IP address is the exact same across two different locations. So we have this IP address 1111 that is connected to R2, and we have this IP address 1111 that is connected to R3. And the reason of this demonstration is I want to show you in the event here where if the router would send the traffic to 1111, would he send it to R2 or would it send it to R3? Now I still have to configure the rest of this network. I'll do that very quickly. So this is R2, say no, enable, no even, enable config space T, hostname R2, interface gig 0/0, IP address 192.168.12.2, 255.255.255.0, and no shut. Interface gig 0/1, IP address. Oh, sorry, that's done. Okay. Exit. Interface loopback 0. And I'm going to give this IP address up. IP address of 1.1.1.1, 255.255.255.0. Let me just think of the best way to do this. Sorry, I'm just going to think it in my head here. Okay. Yeah. So loopback 1111, 255.255.255.0. Okay. And R3, I'm going to configure R3. So no, enable config space T. Host namespace R3. Interface gig 0/1, IP address 192.168.13.3, 255.255.255.0. No shutdown. Exit. Interface loopback. IP address 1.1.1.1, 255.255.255.0. Okay. So I basically set up 1111 hanging off R2 and 1111 hanging off R3. Okay, guys, please let me know if you have any questions so far on this in terms of the network setup. Okay. Now, if R1 will, if we were to run a ping, I'll say R1. If I was to run a ping here from R1 to 1111, would that ping be successful? So if R1 was to say ping 1.1.1.1, based on what we have there, it's yes or no. Can R1 ping 1111 based on this what we have here?
No.
Yes.
No, yes. If I gave it right, yes. Okay, well, the answer is no, and the reason why is if you look at the routing table, R1 does not have any route to get to 1111. There's no reference for 1.1.1.1 here in the routing table. Not only is there no reference, there's no gateway of last resort. So the gateway of last resort is set that if the router doesn't know about a specific network, then at least it will send a packet to the gateway of last resort. But if the gateway of last resort is not set, well, then it's just going to drop the packet. So if we were to ping 1.1.1.1, nothing's going to happen because the router says, well, I don't know where to send it. Who do I send it to? I have nowhere to send it. Okay. So let's say, let us configure a static route. Okay. To tell R1, in order to get to 1.1.1.1, send it to R2. Okay. So config space T, IP route. Hey R1, if you want to get to 1.1.1.1, actually 1.1.1.0, 255.255.255.0, go via gig 0/0. Okay. So basically, I put in a route there to say, hey R1, if you want to get to 1.1.1.0 network, any address in that network, send everything out gig 0/0. Okay. Now I do show IP route. And now R1 knows about this network here. So let's ping 1.1.1.1 now. Ping it again. Okay. Yeah, we can ping it. Let's do a trace route to make sure it's going to R2. Because it could. Yeah, 12.2 is R2. Yeah. Excuse me. Okay, that makes sense. So we have put in a static route. Apologize for my phlegmy cough here. We have put in a static route on R1 that says, hey R1, in order to get to this network here, which is basically 1111 is part of this network, send it out gig 0/0. Yeah. And R1 says, yeah, great, now I know how to get to this network. Let's say I want another static route, but I want this static route here to send it to 1111 via R3. But I want the primary route to 1.1.1.1 should go via R2. But R3 will be a backup. Backup route to 1.1.1.1 should go via R3. Okay, so I want to set up a static route that in order that if something happens R2, R1 could still reach this IP address 1111, but it's going to go via R3. How would you set that up? Big space T, IP route, static route, 1.1.1.1.0, 255.255.255.0. Now, actually, before I do that, let's just look at something here. Let's just do a snippet here. New. We looked at this before. We looked at this, what's known as the administrative distance. And the administrative distance basically is, who do I trust the most? Right, blue. Admin distance. So it's who do I trust the most? And I don't know if you can remember these. Connected networks have an administrative distance of 0. Static routes have an administrative distance of 1. OSPF is 110. and RIP, which we don't use, is 120. I'm just putting it in for reference. So a static route has an administrative distance of 1, okay? So that means that I would trust a static route over an OSPF route. So if this static route was saying, in order to get to so if this was a static route here, and this route was learned via OSPF, and I ran a ping to 1.1.1.1, who would R1 send a packet to 1111? Would it send it to R2 or would it send it to R3?
Or two.
R2, because administrative distance of static route is 1. OSPF is not trusted as much, so it would be 110. Kind of like the analogy would be you're driving along in your car and Google Maps is telling you to get to Athlone one way, and then your drunken mate who's after drinking a flag of the cider is telling you he knows a shortcut to get to Athlone. Who are you going to trust, Google Maps or your drunken mate? So yeah, Google Maps, I hope. Okay. All right. But the thing is, right, I want to use 2 static routes. I want the primary route to go to R1 via static, which is 1111, but I also want a static route to get to R1 111 via R3. And I put in the static route already. But what you can do is you can use gig 0/1. You can change the static route. You can change the administrative distance of the static route. Let's say in this case, it's going to be 5. So now I've got 2 static routes. If I do show IP route, and I'd actually do a show run. Actually, do show run first. And in the show run, you'll see both static routes together. Okay. So this could be an exam question. Who is the router going to prefer? Is it going to send it out gig 0/0, or is it going to send it out gig 0/1? In this case, the router will send it out gig 0/0. Why? Because the static route has a default admin of 1, where this has, I've changed the administrative distance of this route to be 5. So with static with administrative distance, lower is always better. Does that make sense?
Yep.
So this static route in here has 5. This one here is default of 1. So if it doesn't say anything about the static route, if it doesn't have any admin distance value in the static route, then it's 1. If it has an administrative distance of here of 5, then it's going to be 5. So well, let's do a show IP route. What's in the routing table? It only has 1 route in the routing table, which is out gig 0/0, because that's, you see, with the routing table, only the best route is put in the routing table. So if I was to run a ping 1.1.1.1, it's going to go out. What we'll do, the best way to do this is do what's known as an extended ping on your router. You can do it's not a continuous ping. You do continuous pings on PCs. Ping space -t space 1.1.1.1. You can't do it on routers. You have to use what's known as an extended ping. Ping, press enter. The protocol is always IP. Target IP address, we're pinging 1.1.1.1. Enter. The repeat count, this is where you change it the repeat count. If you want a continuous ping, you can set the repeat count to, let's say, 10,000. There we go. So I'm sending, so these pings or exclamation marks are going across, yeah? So I'm running this ping. Now what I'm going to do is I'm going to bring down R2. I'm going to bring down this link in R2. So enable config space T interface gig 0/0 shut down. That link is shut down. What happened to pings? Still worked. But we're not. So I'll just stop the pings here. I stop the pings and now I do show IP route. We're going to gig 0/1. So gig 0/1 is now in the routing table as a backup route. It was going out gig 0/0 until I brought down gig 0/0, but now it says I can still reach 1111 by going out gig 0/1. Any questions on that, guys?
Nope.
Okay.
Oh, good.
Good stuff. Right, what I'm going to do is I'm bring up this link again. No shutdown. And I'm going to set up R1. So this is static route. I'm going to put in this is a static route. And I'm going to use OSPF. Between R1 and R3. Now OSPF is, so I'm going to have OSPF running between R1 and R3 here, okay? Now I might have to do something with this. Okay, let's just see this, let's see if this works. Okay, so I'm going to set up OSPF between R1 and R3. So config space T interface gig 0/1 IP OSPF 1 area 0. And then go into R3. Enable config space T interface gig 0/1 IP OSPF 1 area 0. There we go. And config space T interface loopback 0 IP OSPF 1 area. So I want R3 to tell R1 that it about the 111 network. So now if I go into R1 and do show IP route, okay, let me just change something on this here. What's this command I'm looking for? Sorry, I'm just going to give me a second to try to. I have to do something in here that's going to be a bit confusing because I want to, yeah, interface. Here IP OSPF process. Okay. Let me just go back in there again for this one. So I can. Okay, cool. That's exactly what I wanted to do. Okay, yeah. So OSPF is a little bit too clever for its own thing. OSPF will, because this 1111 is a loopback, R3 will tell R1 that OSPF is a loopback, and then R1 will say, well, there's only one IP address. I'm not really bothered about that. So I have to tell, so there's a command you have to do, whereas I have to set it up as a point-to-point network. Don't worry about it. So yeah, so, and this is the way it should be. Okay, we have a static route. So there's only one path in here for R1 to get to 1111, which is out the static route of gig 0/0. Where is the OSPF route to get to 1.1.1.1, 1.1.1.0? It's not there. Why? Because OSPF is 110. So the way our administrative distance works now is our static root here is 1, which is default. And over here, sure, let's change that. It's OSPF, which is 110. If I go in to R2 and interface gig 0/0, and I shut down that link, okay, let me go in here, and now I do a show IP root. Ah, okay. The static root here is still coming up because I have to remove it. 1 second. Because I still have this static root here. So there we go. Now the static root, now OSPF is there. Why? Because the administrative distance of OSPF is 110. This static root is 1. Okay, how could I set this up to have the primary root, the 1111 via R3, and the backup root, the 1111 via R2. But I want this to be still a static root.
Set the static distance to 115.
Very good, very good. Yeah, exactly. So I'll do interface gig 0/0. No shutdown. So we'll go back in here now at the moment. So basically the OSPF root is gone again. Why? Because the link is up. So the static root will take charge again, because static roots have an administrative distance of 1. But I don't want, I want the primary root now to be the OSPF learned root. So I'd have to go in to R1. This is it here. And I need to put in 111. Show IP root. Show, I'll just do a show run here first. I have a feeling both roots are going to be in. Yeah, IP root. That should be it. Show IP root. Show IP OSPF neighbor. Something wrong there. That the static root there should be changed. It shouldn't be 111110. Because we've changed, we have changed the network. We've said that we've changed the administrative distance. Show IP root. $311. Let me just remove this. No. There's your OSPF learned there. And we put in a static root then again. IP root to get to 1.1.1.0, go via gig, something mass 245.245.245.0, go via gig 0/0 space. The administrative distance is 115. So IP root. That's the way it should be. Yeah. Okay, that was just a bug with packet tracer. So you can see now the OSPF root is still learned over the static root because the OSPF root is learned is 110, while the static root is 115. Okay. Any questions on that? All good? Okay. So our static route now has an administrative distance of 115, and this OSPF learned route is 110. Okay. So if R1 will ping 1111, it's going to go to R3. Let me just try it out. Trace route 1.1.1.1 is going to R3. Yeah, because of the administrative distance. So our static route at the moment has been manually set to 115, and the OSPF is 110. I'll do one more thing here. I'm going to go to R2, backspace T, I'm going to change the network. I'm going to say interface loopback 0 IP address 1.1.1.1 255.255.254. And let me do one here. So now I'm changing it to a /27. And this one here is still a /24. I'm going to go into R1, backspace T. I'm going to remove that static route. I'm going to put in IP route 11110 255.255.254. Okay, so here we have, so this is the setup here, right? We have a static route going on R1, we have a static route to get to 1111/27, which is a smaller network, with an administrative distance of 115. We have an OSPF network over here with an administrative distance of 110. If I do a trace route here to 1.1.1.1, who's it going to go to? Will it go to
R3.
R2 or R3?
R3.
Why?
The lowest admin distance.
The lowest admin distance. And that is what I've been telling you all along. The administrative distance is who do I trust the most? There is something that trumps administrative distance, and that is the smaller the network, the more specific the network will trump a bigger network. So if I have here 1.1.1/27, which is only 30 addresses, and I've got 1111/24, well, this will trump administrative distance. More specific the network, it trumps administrative distance. So let me check it out. Trace with 1111. It might be working on it. No, let me just 6. Just ping 1.1.1 first. Oh, not even pinging. Why is that not pinging? Let's just check this out. So I do. To get to 1111, yeah, that should work. One. So IP route. Yeah, that should work. This is, yeah, we should be able to ping. So here, okay, so look, the best way to do it in the event of here, right? You can see both of these routes. I know this is very confusing. That we've a static route. This /24, it doesn't matter what the administrative distance is. A /24 or /27 will always be preferred over /24 because it's more specific. It's a smaller network. Okay, it won't even look at the administrative distance in this event. So when you have the same network or something that looks like the same network going out two different interfaces, one is a /27 and one is a /24. Because of /27, the network is more specific, then it will go out there. Is there any questions on that, guys?
Oh,
Okay, so it's called the longest prefix match. Trying to get it on it here. So basically it just means that it's used to ensure more granularity. This is what I'm reading here. So here we go, right? So in this case here, right, 192.24.0.0/18 or 192.24.12.0/22. Which one would be preferred? I'll go away. Okay, well, the /22 would be preferred because, so B would be the next hop. Okay, because don't even worry about the longest prefix match, which is more specific. This network here is more specific, so therefore that's going to be preferred. I don't like using the longest prefix match because then you're getting into the bits and sometimes they can be a bit confusing then. Okay, so the smaller the network, the more granular the network, the more the preferred route. Okay, and that will take precedence over administrative distance or over everything else. Now I know there seems to be a problem here when I do a trace route to get to 1.1.1.1. I don't know why it's not working, but that's a bug in Packet Tracer because we can see here it has both there. If I shut down gig 0/0, it's the interface gig 0/0, shut down. Oh, 13.3. Yeah. All right, guys, I think that's it. Is there any questions over anything there now we can have a chance to talk about? If you want me to go over, we've still got a couple of minutes left. This administrative distance or SNMP or syslog or AAA security, the radius server, TACAC server. Anything there you want me to go over?
not right now. Thank you.
All right. Okay. Cool. But see you tomorrow. What we're going to do is we're going to do a lab tomorrow on multi-layer switching. So yeah, we'll have Packet Tracer. We'll do a Packet Tracer lab tomorrow. Yeah.
Cheers.
So a multi-layer switch is basically you have a switch that will do routing as well as switching. Layer 3 routing as well as switching. Basically, it's like a router with lots and lots of ports. Okay, and we'll talk about that tomorrow. All right, guys.
Thanks. Thank you
Thank
very
you.
much.
Thanks.
Thanks.
Good luck.
Bye bye.
Thanks, Pat. Bye-bye.
Guys.
Cheers.
Thank you.